Buenas tardes. Good afternoon. Blandi, please let me introduce to my colleague and audience in Spanish. Thank you. Estimados autoridades, directores, académicos, investigadores, científicos, algún estudiante también, estudiantes, y todos los invitados a estas charlas. Para mí es un placer presentar a nuestra invitada, Blandi Lee Macdonald, profesora del Departamento de Química de la Universidad de Missouri. Blandi realiza investigaciones en el laboratorio de arqueometría en el estudio de la procedencia de pigmentos ocres, arte rupestre, cerámica y obsidiana. Blandi se especializa en estudios de diversos materiales arqueológicos en muchos lugares del planeta, incluido América del Norte, Australia, Europa Occidental, Patagonia noroccidental y el sur de África, mediante técnicas de análisis como activación neutrónica, espectroscopía de fluorescencia, rayos X, espectrometría de masa con plasma acoplado inductivamente y espectroscopía Raman. Solo un segundo, que olvidé sacarme la chaqueta y tengo un poco de calor. Gracias. Que afuera hace mucho frío. Ahí sí. Me saqué un peso de encima. Gracias. Entonces, como mencionaba, Blandi ha hecho análisis en distintos lugares del mundo y diversos materiales arqueológicos, muchos lugares del planeta, incluido América del Norte, Australia, Europa Occidental, Patagonia noroccidental y sur de África, mediante técnicas de análisis como activación neutrónica, espectroscopía de fluorescencia rayos X, espectrometría de masa con plasma acoplado inductivamente y espectroscopía Raman. Blandi ha visitado esta semana nuestro laboratorio de espectroscopía vibracional en el Departamento de Química, junto a la doctora Marcela Sepúlveda, presidenta de la Sociedad Chilena de Arqueología y investigadora de la Universidad de Tarapacá, a quien también agradecemos su presencia. En esta visita analizamos algunas materias primas de arte rupestre del norte chico en nuestro país. Como antecedente, en nuestro laboratorio de espectroscopía vibracional hemos trabajado con técnicas de espectroscopía Raman e infrarrojo, estudiando materiales de interés patrimonial, como muestras de arte rupestre, textiles prehispánicos del norte de Chile y tejidos humanos momificados, en la búsqueda de interpretar la producción de objetos arqueológicos y los materiales que permiten favorecer su conservación. Aprovecho de felicitar a Marcela por la adjudicación del proyecto Fondesit, que nos permitirá caracterizar los componentes que otorgan color a materiales del Imperio Inca entre los siglos XV y XVI. Me gustaría recalcar que el seminario en que se enmarca la visita de Blandi es una instancia de difusión, colaboración e intercambio interdisciplinar que puede convertirse en una oportunidad para nuestra facultad, que potencien futuras estadías de investigación de nuestros estudiantes de posgrado, con carácter multidisciplinario y transversal, acorde a los lineamientos de la Universidad de Chile en su plan de desarrollo institucional. En cuanto al trabajo multidisciplinar, la química, la física y la arqueología convergen en la arqueometría, donde se utilizan diversos análisis que permiten obtener información microscópica, molecular y elemental de materiales arqueológicos, facilitando la interpretación de procesos de culturas ancestrales. En ese sentido de colaboración multidisciplinaria, el proyecto Fondesit de la doctora Gloria Cabello, del Departamento de Antropología de la Facultad de Ciencias, sociales de la Universidad Católica, quien colabora con Blandi, ha realizado su investigación desde la perspectiva de la arqueología. Con estos antecedentes, me gustaría ceder la palabra a Gloria y luego a nuestra invitada, Blandi Lee Macdonald. Gloria, te cedo la palabra. Muchas gracias.
Muchas gracias y bienvenidas a todos y todas. El proyecto Mundos Vividos Itinerancia Rupestre en la costa del desierto de Atacama estudia los vestigios arqueológicos de lo que va entre el río Loa y Copiapó, en el norte de Chile, particularmente el arte rupestre, pinturas y grabados e incisos que superan ampliamente lo conocido en la literatura arqueológica. ¿Y qué es lo que vemos ahí? Imágenes y objetos que responden a los desplazamientos y relaciones sociales establecidas entre las poblaciones cazadoras recolectoras y pescadoras del borde costero desde hace al menos unos 10.000 años, pero también mediadas por las interacciones con las poblaciones del interior. Creemos que las personas experimentan lo vivido mediante un mundo propio, personal, y un mundo exterior, muy lejos de su cotidiano. Mundo que es vivido a través de viajes y relatos propios, que incluyen también los de otros. Experiencias en cuyo medio habitan seres, actos, cosas, entidades y conocimiento. Habitamos este mundo real e imaginario, dejando huellas tangibles de nuestro paso por esos lugares, que son nuestro mundo vivido. A nuestro paso quedan vestigios materiales. Quisiera agradecer a la doctora Marcela Sepúlveda, coinvestigadora que lidera los aspectos arqueométricos del proyecto y quien propuso, convenció y acompañó a Blandi en esta aventura. Agradecer también a los compañeros de Marcela por tantos años, Sebastián Vivanco y José Cárcamo, por aceptar este nuevo desafío, así como a Álvaro Aliaga por recibirnos en el laboratorio de espectroscopía y vibracional de la Facultad de Ciencias de la Universidad de Chile. Estoy segura que con la experiencia de este gran equipo tendremos fantásticos resultados. Gracias. Voy a poner la presentación de Blandi.
Hello, hola. Thank you for your patience with me today. My Spanish is not very good, but I hope you can understand what I'm going to be talking about today in English. I wanted to start by saying a deep thank you to Gloria and to Marcela and for the Department of Chemistry to invite me here to be part of this project and also to speak with you today. It's been a wonderful 2 weeks. As you've already seen some out-of-the-field photos, very fast publication, right? It's been a wonderful time. So what I'm going to be talking to you today is about a project that I'm working where I've applied similar techniques in archaeological chemistry to a different study area that I hope to support Marcela and Gloria's research here. And so I'm going to take you on a journey to Southern Africa, to a small country called Eswatini. And this is a project I've been involved in since 2017. But first, I'm going to tell you a little bit about myself, very briefly, so that you can understand the analytical approach and the techniques that I use in my lab. And then I'm going to go deep into this case study. And so I'm the PI at the Archaeometry Lab at the University of Missouri Research Reactor. And you're probably wondering why an archaeologist would care about a nuclear reactor. I have had the good fortune to work in not one, but two nuclear reactors through my training. I did my PhD at McMaster University Nuclear Reactor in Canada, where I'm from. And I started working there as an undergraduate in 2004. So this is actually the 20th year that I've been working in this type of facility, and I've been able to get very specialized training in archaeology and geochemistry and physics to really understand these techniques. And so particularly, I use neutron activation analysis and X-ray fluorescence. I also, when I'm not too busy doing research, I'm a managing editor at the journal Archaeometry. So this is a really good international journal in our field of research. And I'm also a board member on the Society for Archaeological Sciences Executive Board. And so these are some of the activities that I am involved in. And so you're probably wondering, again, why would an archaeologist care about a nuclear reactor? How did the program of research grow to be what it is today? And so some of you might know this, some of you in chemistry might know a little bit about this history, but after Oppenheimer discovered nuclear fission, there was in North America a proliferation of nuclear reactors. And this was sort of this big golden age in nuclear chemistry and physics. And all of these universities built all of these small reactors. And so the technique specifically of neutron activation originated out of Brookhaven in California in the late 1950s. And around this time, it was a little bit later, but in 1966, the University of Missouri Research Reactor was constructed. And so since the late 1960s, we've been in continuous operation. And one of the key issues with nuclear research reactors these days is that they're very expensive to operate. A lot of universities can't afford to keep maintaining them. So a lot of them have been decommissioned in the 1990s and early 2000s. So where there used to be 200 or 300 of them operating in North America, we're now down to about 3 dozen of them still in operation. And this is why our lab is very important, because there are not as many places that you can go and collaborate and do these types of analyses. And so the archaeometry lab that we know today originated out of this initial program. And so the former director of the reactor, who initially helped to build it in the 1970s, his name was Dr. Jim Vogt. And he was a physicist, but he was very interested in archaeology and chemistry and forensics. And so in the 1970s, he started this program. In 1979, how many of you know who Dr. Mike Glasscock is? Probably a lot of you if you've worked in archaeometry. So at the time, he was just a postdoc in 1979. And he joined the reactor and put a lot of energy into developing techniques like neutron activation analysis. And he oversaw this program from 1988 until he retired last year in 2023. And another important crucial aspect of how our lab has become how we are today is in 1987, 1988, the National Science Foundation started a new funding program called the Archaeometry Program. And so we have continued to receive funding from this program for now 36 continuous years. Hopefully we will continue. We have our new renewal this year, so every 3 years we reapply for funding. And they provide funding for us to then subsidize research for archaeologists all around the world. And so between that period in the 1990s, our analytical capacity started with NAA but have broadened. So now we do X-ray fluorescence, ICP-MS, and different types of mass spectrometry and Raman spectroscopy. So this is the role that we play in the community. Primarily neutron activation of clays, ceramics, and sediments. We also recently have started doing isotope analyses, so strontium isotopes, lead isotopes, neodymium and uranium for other types of provenance, human migrations. We do a lot of X-ray fluorescence, so not just obsidian research, but also in situ analyses, like the project that I'm going to be talking to you about. And recently, we have started doing more Raman spectroscopy. So we have 2 benchtop models and 1 portable model. And I've shown you these interesting fieldwork photos where there's a lot of bending and stretching and holding and complicated scenarios, but it's very fun. So this is what our lab is about. And so I wanted to share that with you so you understood a little bit more about the application that I'm going to be talking to you about. So now we move to Southern Africa. I'm interested particularly in the provenance and use of mineral pigments and how they tell us about human interactions and mobility and long-distance exchanges in the past. And so this is part of a large collaborative project that I'm working on with colleagues in Germany, Norway, South Africa, Eswatini, and England. And so we all have different areas of expertise, but what I'm interested in looking at is ochre provenance. So looking at hematites, different iron oxides that were used, we know, at least from over 40,000 years before present up until the Iron Age and historic period. And so the project uses archaeological materials that have been excavated in the 70s, 80s, and 90s by a few archaeologists who have worked in the area. And we've also done some new surveys and new excavations in the country. And so the approach that I take uses a combination of geological surveys collecting local raw materials and using different techniques such as neutron activation and X-ray fluorescence to identify the sources from which these materials came. So here's the tiny country of Eswatini. You can drive across it in 3 hours. It's very tiny. If you are not aware of where it is, it borders Mozambique and South Africa here. And there's a really rich history here of archaeology. We have, many of you maybe have heard of Border Cave, which is currently one of the oldest known human remains, just on the border. Apparently it's in Eswatini, but South Africa thinks it's in South Africa, and it's in a cave in between them. They fight over it. But anyway, this is an area of really high historical significance in terms of human evolution. And so we study a series of sites and ochre sources all around different parts of the country. Here you have, on the western area, we have this is a high veld. This is a very high elevation mountain area with a lot of hydrothermal deposits. And then we have the center. This is the low veld. It's a low-lying area. And then on the east, this is a very relatively young volcanic belt mountain. And so although it's a very short distance, it's actually quite complex topography. And so the most well-known source of ochre pigments is at the Ngwenya complex. So this site here is Lion Cavern, or what's left of Lion Cavern. So we know that mining activities here have gone on for, actually this is not a new date, we have newer dates, around 48,000 years BP, before present. And so there were actually 4 mining sites along this whole deposit. But in the 1960s and 1970s, they went in and mined out for iron ore. And so they destroyed a lot of the sites, and this is all that remains, for the most part, in this main area. And it's a massive, beautiful, gorgeous site. We still see tools stuck in the, in the deposits. It produces some of the most beautiful pigment I've ever seen. It's amazing. This is a side profile showing some of the deposits that are still intact. So they blew out all of this with dynamite, and then they just left a little bit here. But in this side profile, we're still finding stone tools, charcoal, etc., from human activities. But again, it produces a whole range of actual different colors. So we have yellow goethites, we have these blue-gray ironstones that when you grind them, they make a beautiful blood red paint. We have really nice soft hematite. And so it's an important source, and we know historically that it's been used for a very long time. But it's also not the only source of raw material that can be used to make paint. So down in the lowland areas, we have other examples of things like these saprolitic iron-rich clays that are full of mica and iron, and they make a really beautiful color, and they're very soft. They also co-occur with these beautiful kaolinite deposits. I like to include this photo because this is such a gorgeous boundary between these two different types of raw materials here. And people still use these today. So a lot of people go and collect these and sell them at the markets. So this is still a practice ethnographically that's happening today. In the south of the country, we also have this big iron ore deposit called Maloma, and it produces some very nice paint. We have Kubuta, which is actually a manganese oxide ore deposit, and we can see a lot of the remnants here of pits that were used because it's a surface deposit, it's fairly flat. So these were all dug out pits that are now, you see the spoil left behind from the mining activity. And so this is all just to show you that there's actually quite a high diversity of different raw materials that are available throughout this relatively small geographic area. So there's a lot of options. People can choose different types of materials. So after going through and doing our geological survey and comparing these, we wanted to compare these two artifacts. So we have two main large archaeological sites that have really deeply stratified deposits. So one of them dates back to the late Middle Stone Age, and the other is the entire late Stone Age sequence. And so we went through these excavated assemblages to try to identify what kind of ochres are they using, and can we identify how they're using them. Interestingly, only a few of the artifacts, of the 931 that we studied, only 7 of them had use wear, which, if you're familiar with this is actually very rare to have such a small amount. So this is something interesting that we're looking into more. So what I'm interested in is looking at the provenance, right? So when you have these artifacts from archaeological sites, can we tell where they came from? So we started by doing a typology, so looking at the macroscopic characteristics, followed by neutron activation analysis of the iron oxides, and laser ablation ICP-MS of the manganese oxides. And there's a reason for this, because you can't analyze manganese oxides by neutron activation. It's actually dangerous, it gets very radioactive, so for practical reasons we can't. So I decided to use a different technique. And then we supplement this elemental fingerprinting approach with mineralogical characterization, using either X-ray diffraction or Raman spectroscopy. So we've been working on this for quite a while, and now the whole database for the whole project has over 550 samples. So the idea really is to, can we identify change over time, over very long periods of time, and networks. So with this, in terms of the sources, we've been able to differentiate the majority of the sources based on their element chemistry. So what you're looking at here is a principal component analysis of the results of neutron activation analysis data. So each one of these points is a data point, so it's a sample from a source, and the ellipse represents a 90% confidence interval of the clustering of this group, of this source. And so when we look at this statistically, using, this is one visualization of many different visualizations, we want to know, does this satisfy the provenance postulate? So this is a very fundamental concept of all sourcing studies. Are your sources different enough from each other that you can separate them? If you can't, then you can't do provenance very well, or there's limitations, right? This is one example of looking at all of the artifacts. So we have done over 370 artifacts over 9 different archaeological sites. And this looks like a bit of a mishmash, but when you start separating these out, you can differentiate these compositionally distinct groups. And then we decided to start comparing the artifacts to the sources, right? Can we then link specific clusters of these artifact groups back to sources? And so we've been able to differentiate between the western region and the eastern region of the country 2 very different modes of procurement, and I'll show you what that looks like in a moment. And these are the manganese oxides. So there were fewer manganese oxide artifacts to make black paint, violet and black paint, but there were, I believe, 57 of these samples, and these also separated out very nicely. So what does this mean? This is a stratigraphic profile of the artifact assemblage at Sebebe. So this is one of the sites where we have components going from the final late MSA, around 44.7 to 42.9 thousand years ago, all the way up to roughly 2,000 years ago. And it's complex because there are a lot of different sources being used, but what we can see is a general trend in a decrease in the diversity of sources over time. And so when I first observed this in the bigger picture, I asked myself, is this mean that there was maybe decreased mobility, so they're choosing to use fewer sources, maybe they're not moving around as much as they're adapting to the environment? Maybe this is a period where you have less intensive social networks, so there's less movement around, less reason to socialize between hunter-gatherer groups. And I also noticed that there's an increase over time in preference for different colors. So the manganese oxides become more prevalent, proportionally more prevalent in the late Stone Age. Now there's another site on the far east of the country where the pattern is very different. So we actually see a really high diversity of sources being used over time. Again, the sequence dates between 14.8 thousand years ago up until 300 years before present. And so we see a really high degree of mixing of different types of sources up until roughly this period, up until the last sort of Iron Age deposits. And so this is really a strong contrast between these 2 archaeological sites. So we have completely different provisioning activities that are happening over time. And so I'm asking myself, does this mean that the people living at this site, at Sepiso, do they have a wider mobility range? Did they have more intensive social networks? We also know that some of the ochre in some of these smaller groups is actually being transported really long distances, over 120 kilometers. So when we look at the bigger picture, what are we learning through this provenance study? At most of these archaeological sites, so Sebebe and Sepiso are the large main sites, we see the predominant use of local materials. Surprise, right? Sebebe, they're mostly using ochre from Ngwenya and from Bulembu. And at Sepiso, they're using local ochres, but we don't know the source of them. We see them present in the archaeological assemblage, but we still don't know exactly where they've come from. We haven't found them yet. But we also do see movement of Ngwenya ochre over to Sepiso. We also see movement of ochre from the south here up to Sibebe and up to Sipiso. I tried drawing this map with arrows and it just looked like a big mess. it's not very intelligible, but you have to imagine you actually have these really intensive circulations happening. We see, again, long-distance transport of iron and manganese oxides, but it's always a very small percentage of the proportion, usually less than 2 or 3% of the assemblage. So for 30 years, people working in this area, every time they found ochre, even at Border Cave, they said, oh, it must have come from Ingüeña. It's the best ochre from Lion Cavern. It's being transported long distances. We're actually not seeing that. That's not the case at all. We're also seeing more broadly information about how people are moving east-west, how frequently or infrequently they're moving between these very different ecological environments, between the high veld, middle veld, and low veld. And we're also seeing kind of only limited evidence of things. It's actually a very small proportion of things that are moving from the south. So there's not as much social connectivity between inhabitants here and up in this middle veld area. What still has kept my interest is understanding why you have very different procurement modes between the east and the west. Does this signal something about the social relationships between people in this area? And another thing that is interesting to me is we do have other sources in this area. So Mnyongane and Lufolo Dam are very beautiful materials, but we never see these in the archaeological record. They're present in the landscape, but they're never choosing those ochres, which I think is interesting because it may signify some sort of special association to Ingüeña, or perhaps some sort of taphonomy, because this is very clay-rich ochre, and maybe it doesn't survive as long in the archaeological record. And so the concept that I'm thinking through now with these ideas is really trying to understand it through the lens of a communities of practice. And for those of you who study pottery or different types of stone tool technology, this is a concept that we use to understand how information is learned and transmitted through multiple generations. And so the big picture in Eswatini that I think is happening is we have this unifying cultural significance of ochre. It's been important to these communities for, over 40,000 years, consistently important. Yet we have very different contextually contingent variations in how they approach this material, how they collect it, how they process it, the types of minerals that they choose. And so, to me, it's interesting that we have this continuous use of ochre, for instance, from Ingüeña, because these are high-veld sources way up in the mountains. This is not where people lived, right? So you would have to go up to collect these as part of regular traversals around the country for specific reasons, and this is knowledge that had to be passed down from generation to generation. The amount of ochre that was also mined from Ingüeña was such an enormous amount, like they're talking hundreds of tons of this material when the archaeologists arrived in the 60s. This would have required group cooperation and that material knowledge and understanding where in that formation you could actually mine it, the types of tools that you had to use, because this stuff is extremely hard to mine. It's not soft. And so you have this shared body of practice and understanding how to actually collect and use this material. And so to me, this is all really signifying these intergenerational communities of practice. So that is part of a study that we are publishing now. But there's also another component that we're just starting, and I'll show you a few images, where we're expanding our provenance research in looking at rock art. So looking at artifacts and sources and understanding the variation is really important, but then we want to get into our next steps, because there are, in this small country, there's over 50 different rock art sites. And so right now we have, for instance, excuse me, one PhD student. Her name is Ayanda Mabuza, and she is studying the stylistic variations of different rock art styles in the country. And so she is just finishing her PhD in Tübingen in Germany on this right now. And what I am looking at, working with her, is trying to understand variations in those raw materials that were used. So using the same portable instrumentation that was mentioned earlier to do in situ analyses, to be able to see, looking at monochrome, bichrome, and polychrome paintings. We have colors, all different colors occurring at many different sites. We have reds, violets, yellow, white, black, orange, and what I'm calling an ochre wash. And I'll explain that in a minute. And so using a chemometric approach, can we identify different recipes or mixtures? And this is something that, for anybody who's worked with rock art, knows that this is extremely challenging. Rock art sites are very unique geologic environments. You have interactions happening beginning from how people are actually creating paint, making mixtures, applying the paint, how the paint adheres to the rock surface, the environmental condition, different degradation products that happen, different environmental contaminations. There's all of these different factors you have to consider when you're studying these, particularly in situ. And so it's not a simple approach, but if you're really interested in it, you can invest a lot of energy. And so we've looked at 8 sites to date across the country, and we've chosen some of the biggest sites where we have the most motifs. And so we're going through and documenting them and using some of this portable instrumentation. Yes, that's me hiding in a corner. There's actually little motifs inside of this crevice. Don't worry, we checked for snakes before I crawled in there. But this is a very typical example of these rock shelters where a lot of these rock art sites occur. This is another example of Inshlodzane rock shelter. A lot of these motifs are mostly things like animals, different eland, reebok, African kind of animals. And then there's another tradition where there's a lot of human figures. But this is a very different artistic tradition. This is one example of some dancers with no heads on a dancing scene at Inshlodzane. And then this is, for instance, what I referred to as an ochre wash. And so this is a rock shelter site. This is Sebebe. This is one of the oldest sites in the country. And this is where there's the practice of, there are shamans who still practice medicine, traditional medicine here. And they take ochre and they mix it with clay and they cover the whole wall in it. And they don't actually make any motifs, but they cover the walls, and they create this environment when they go into trance and they do dancing and ceremony and take drugs, like hallucinogenic drugs, because they believe red is the way to communicate with the ancestors. So this is a cultural practice that even continues today in some areas. And so some of these sites, we only have this big wash here. But these are deliberately applied. These are not environmental. And so I'll show you a few results from Insanguini rock shelter. And I chose this because it's a very well-documented site, and there was an excavation where we did find artifacts from the Middle and Late Stone Age. And we have multiple polychrome paintings in different styles. This is also a modern tourist site where people come and hear stories about some of these features. And so we have combinations, for instance, of charcoal and manganese oxide used for black. We have hematite and magnetite used for reds. And we have some yellow goethites as well. And so this is just some preliminary data of looking at the pigment groups based on the Raman spectroscopic data. And we still have a lot more information to add, but we can see that there's actually some compositional differences in what are these mulberry paints, these really dark, beautiful, thin humanoid figures that are really rich in magnetite. We also have this orange-red, which is more of the softer hematite mixed with clay. And we're also seeing a combination of manganese oxides and charcoal being used at the site. This is sort of another depiction. Each of these data points represents an in situ measurement. And so we also have now microsamples that we've taken, so now we're continuing to do the Raman spectroscopy using instrumentation in the lab, which is a lot better than some of the portable instrumentation in this environment. It's a challenging environment. So you can see, again, this is this beautiful mulberry colored paint. And when you look at these under scanning electron microscopy, you can see that these particles of this paint, they're super densely packed. They almost look like clay minerals, but they're not. And there's mixtures of magnetite, pyrolusite, and pyrite. So you have iron sulfides and manganese oxides. We have some of these yellow paints where we're identifying goethite, hematite, and anatase. They're quite rich in titanium. And finally, we have these ochre washes, which are a combination of hematite, magnetite, and clay minerals. And so this is work that continues in progress. Oh yes, and the black figures. We have bixbyite, manganite, and there's also signatures for charcoal, but I think it might actually be from fires, because this was a rock shelter where we had a lot of fires. So this might be just sort of emitting the soot that's been emitting from there. So not sure yet if that's intentional or natural, or, you know. So what's next? We have been fortunate to have a lot of new instrumentation at the archaeometry lab, and so what I'm interested in is trying to apply highly sensitive techniques. I'm interested in trying to see if we can identify any animal or plant products in some of these paintings, if they're still detectable. Of course, we have lots of issues with degradation, but I still think it's worth trying. We recently got a new instrument, a FIB-enabled TOF-SIM, so time of flight secondary ion mass spectrometer that is coupled to a scanning electron microscope. This is an extremely powerful tool for looking at trace element fingerprinting at like sub-micron scale. And so one of the challenges with looking at paints is you actually have degradation, you have very small trace amounts of paints. So being able to have really high sensitive mass spectrometry coupled to the electron microscope is pretty amazing. So right now we're building a custom reference library of raw materials to be able to compare to the archaeological samples. We also have a proteomics center at our university. And so what we're trying to do is see if we can identify any of the remains of organic materials that were used as binding agents for the paints. So this is the commonly used ones in this area are eland fat. So eland is like a large ungulate. Snake venom, blood, urine, and different types of plant resins. And so right now we're in the process of collecting all of these raw materials and mixing them with paints and doing some degradation on them to see if we can, compare different signatures. And so we actually partnered with the Eswatini Anti-Venom Foundation. There's actually a family who milks highly poisonous snakes, and you can buy snake venom from them. And I smuggled it back into America. Um, hopefully did not get caught at the airport, but they used venom from black mamba, spitting cobra, some of the most venomous snakes in the world because they have spiritual potency, right? And so, yeah, I purchased some of that, and it's in my office now, and I'm scared to open the jars, but that's part of the future of what we're going to do. And so this is the next sort of steps we're going to do. And so I'll leave you with that and be happy to answer any questions that you have about this research. And thank you to all of my collaborators across the world who've been participating in this project. And we've had funding from the German Research Foundation, the German Archaeological Institute, and through my institution at the Archaeometry Lab. So, thank you. And I think we have a few people who could translate if you have any questions.
Thank you so much, Blandi. Hello. Preguntas, consultas y nos haremos el gusto de traducirlos. ¿Sí?
Well, thank you first for your presentation. I have a question regarding, because you say that the country is a very small country and you're looking at mobility east-west. But what about mobility between Eswatini and Mozambique, for example? Because it's not, because you say, well, it was supposed to be an east-west movement, but apparently it's not. Can you actually talk about the movement from eastern Eswatini towards Mozambique, for example?
Thank you, that's a very good question. We are currently working on some of that right now. So in the northwest, up in KwaZulu-Natal, we have some colleagues who are now looking at, for instance, chert sourcing. So they have a lot more lithic raw materials that are more abundant. And we also now have a new graduate student, Daneo Macia. She's at WITS, and she is working on some of the assemblages from Border Cave. So we're going to start comparing and moving outside. The differences for export permits between Eswatini and South Africa are very different. So in Eswatini, they allow us to, within reason, collect samples and do some small destructive analysis. But South Africa is very, very strict. So we've been trying to develop in Eswatini the capabilities first so that we can then go to our colleagues and say, hey, look, this works. We think this works. So we're working on it.
Very nice presentation, Blandi. Thank you. I'm very interested in the communities of practice approach. Maybe I didn't understand, but have you been able to identify something other than the procurement, than the source, kind of the recipes, mixtures, or what other type of information from the pigments a part of the pigment proper?
Mm-hmm. I think the main aspect of that community of practice is the raw material selection. But we also, of course, see the common use of it, right? And so it's evident that people are, at all of these sites, people are mixing and making paints on site, and they're creating rock art with the same raw materials. So I know it's not the same as like ceramics where you can identify forming and firing, etc. But there are still, raw material procurement and shared use of sources is kind of the main shared knowledge. We think there's some evidence of heat treatment of some ochres, particularly in the east, because they aren't very rich in the colors. And if you heat those ochres, they turn more of a bright red. So we think there may be some heat intervention happening, but we haven't studied that systematically yet. But, yeah.
Thank you so much, Blandi. You talk about ochre wash. Why this name, ochre wash? I said it's like stains that you said that the people do take pigments and make stains like in the walls of the shelters, not?
Yeah, it's like a big stain. A wash is like what the local people call it,
okay.
right? Yeah, that we wash it with ochre. They actually mix it with pig fat.
Oh,
Yeah,
interesting.
to make it smooth, and it's a lot of the surfaces are granite, so they're very porous, right? And so sometimes if you just apply the paint, it kind of sucks in and it doesn't stay very much. So they mix it with fat and like really pack it on.
And it's only red? You said that red is the connection with the ancestor, no?
Yes, red is a very significant color to their worldview, their sort of the connection with the ancestors. So they also use this in, of course, ethnographic analogy does not explain everything, but we see, for instance, modern Siswati women, when they get married, their wedding ceremony, they cover themselves in ochre because when she marries into a man's family, she needs protection from their ancestors, and she needs to be introduced to the ancestors of his family. It's part of this cultural practice, right? So it's always this red ochre that's this very significant color.
Thank you. But at the beginning, you mentioned also that actually the people get also the pigments. It's like this practice, like body painting, and what other uses they gave for the painter?
It's sometimes used medicinally too. So, for instance, I didn't show a photo of it. I should have shown a photo. The clay sources where they're still digging out these really nice yellow and orange ochres. They process these by levigation. Do you understand this term? It's when they mix it with water and filter it out and just create a very fine fraction of it. And then they pack it into these balls like this big, and they dry them out in the sun, and then they sell these balls. And so if you want to use it on your skin, you just put a bit of water and you rub it on your skin. And it's used for skin conditions, and sometimes it's eaten if you have stomach problems as well. That's what the women at the market told us. We bought some and we're like, what do you do with this? And they told us all of these properties. So,
excellent, thank you.
Thank you for your presentation. I have a question regarding the last issue regarding the fractionation. There are some evidence of fractionation in the pictures in a similar manner than the body paint that the culture uses?
like the preparation of it? I'm not sure yet. We're just starting to study the rock art paints, the little fragments under high magnification, just to understand how they are situated on the rock face and if they can be prepared. There are some, as you saw, were really well laminated, like this kind of raw material, which is really densely packed and fairly uniform, right? But then you have some of this stuff where it's all sort of like crushed up and mixed in and combined with, this is the ochre wash, so this is actually mixed with clay. So you have different particle sizes, they're all oriented differently. This is another example of, this is a black paint, really extremely fine-grained, but like angular, not flat. So we're looking at these sort of different characteristics to see if they match the sources or if we can see the same type of preparation between the sites. So it takes a long time to build up the knowledge, right? So.
Otra pregunta,
Okay, thank you.
Thank you very much.
Yo, thank you so much, Blandi, for these 2 weeks. It was a pleasure for me to be with you. El Departamento de Química hace entrega del certificado.
En español, inglés, English.
Thank you.
For you.
Thank you.
And a gift for the University of Chile.
La piochita de la U. Importante.
That's beautiful.
La foto, pues.
Yeah?
Yes. Ya, eso. Agradecer a todos entonces por su asistencia, participación. Y ahora, no, es que no me corresponde. Bueno,
Sí.
a nombre de Álvaro, invito a compartir cordialmente a todos un juguito, un café, un vituperio antes de partir. Eso. Muchas gracias.